I will talk about EvoKex, the way to improve program analysis and test generation. Here's outline, and let's dive into this theme. Well, basic idea is that we have two tools to generate tests, EvoSuite and Kex. They are quite popular because writing tests using people is expensive in terms of time and resources. So these tools are quite popular. And we wanted to make use of advantages of both of these tools, because one of them is a search-based software testing tool. It has fast and efficient approach. However, it is some kind of random, and therefore struggles with some complex cases to cover them completely. On the other hand, we have a symbolic execution tool named Kex, which is resource intensive. However, this approach is much more stable because of its nature. So what we want to do is we want to have a fast and efficient and stable tool. And let's see, can we do it? To start things up, I will talk about EvoSuite. EvoSuite uses a genetic algorithm. And the idea of genetic algorithm is to mimic evolution process. We have several epochs or stages. On each epoch, we have a population. It is some number of individuals. Each individual is somehow selected or not selected based on their value, decided using fitness function. After selection, all of individuals come through crossover and mutation. Crossover is when we take two parents individuals and we somehow merge them. We take chromosomes from each individual. Chromosome is like a building block. We merge them somehow, and we have a new individual, like child. After that, we mutate all individuals. Mutation is like insertion, new chromosomes, deleting old chromosomes, somehow changing them. And the difference is that in crossover we have two individuals, and in mutation it is only one. And this cycle repeats until we have time or until number of epochs that we want to see is not completed. So EvoSuite uses this genetic algorithm. Each individual is a test case. It consists of statements, and EvoSuite is targeted at Java, and so we have Java statements as chromosomes, and fitness function that is used for selection is basically line coverage. The better line coverage after this test is, the better the test is. Another important part is Dynamosa algorithm. It is algorithm that about dynamically choosing what target we want to what branch we want to cover. I will talk about it a little bit later. Here is how crossover looks in this case. We have two individuals. They consist of chromosomes, and their child is somehow chosen chromosomes from both of the parents. That's pretty much easy. Mutation. There are several types of mutation. For example, insertion that can be seen here. We just added a new line of code, new statement, and changing of existing lines, existing statements is here. We changed the value of a variable. Now speaking of Dynamosa, basically what we want to do when generating tests, we want to cover different branches. In the code in real life, we usually have a lot of branches and we want to cover each of them, but we want to understand which one we want to prioritize in each case. But for some reasons, in different points of time, we want to prioritize different things. For example, here we have 4 branches and we can prioritize covering each of them. But if B1 is uncovered, then covering B2 and B3 is not very smart from our side. We need to cover B1 we need to start from covering B1, not B2 or B3. And choosing this most prioritized branch is basically a Dynamosa algorithm. To sum things up, we have a tool that is efficient and fast in most cases, and easy to extend and feature. Like we can add new mutations if we want, we can tune it and so on. But however, it has a couple of disadvantages. For example, as I mentioned, it struggles with complex cases because somehow it can be only one set of features, for example, that cover specific branch, and it can be hard to guess it. It is called flag problem. And due to randomness of nature, it can be hard, and it somehow and it is also a problem that is called fitness landscape problem or coverage plateaus. What does it mean is if we see plots of coverage over time or epochs, we can see that we often have these horizontal lines, and it means that for a number of epochs, we don't see any changes. Our new populations are not bringing that new breakthrough that we want to see. And that's the problem. That's the main and crucial problem with EvoSuite, and it happens very often, even in simple cases. Speaking of KEX, this is the second tool. It is Symbolic execution tool. I will not dive deeply into what is it. Thank you to Rustam. Basically, we are executing program abstractly. It gives us multiple concrete inputs, and each program is some kind of symbolic value or like a set of constraints. We need to choose a path to cover. In this case, we want to cover the code that leads us to the throwing exception. We collect constraints along this path, orange ones, and we solve an obtained formula like we need to have x more than larger than y, and both a and b are larger than 1. And we use SMT solvers that were mentioned to solve it. So it has its own pros and cons. As I said, it is not random approach. It is very stable because, like, if given in ideal world infinite time, it can solve pretty much whatever you want if the SMT solver is strong enough. And it can be used not only for test generation, but for program analysis as well. But as I said, it is resource intensive. As Rustam mentioned, it has a path explosion problem. Like if we have a cycle here, it is more than 1 million of ways to execute this code. It is, however, it is like 7 lines. And the third problem is aliasing. Well, we sometimes have different names for the same part of memory, and we need to be sure that we correctly understand which name is where each name points to. Yeah, and so the first idea of combining these two tools was implemented by Rustam, and the idea was that on coverage plateaus, when we detect it, we can apply KEX so that we generate new test that covers uncovered, because we can like solve it stably, and these tests somehow will improve our coverage and help us to converge faster. And the algorithm was as follows. Rustam took EvoSuite's pipeline and just added a plateau detection. And if plateau detected, we run KEX iteration by collecting constraints like what is covered, what is uncovered, selecting what should be covered by KEX, and generating new tests. After that, they are going through the whole evolving process. And that's why sometimes KEX iterations we're not bringing breakthrough right now, but in some future, they helped EvoSuite to break through plateaus. And this is the results for first version of EvoKex. As you can see, results were a little bit better than baseline. The problem here is that it didn't bring much because KEX iteration is very long in time. Even for generating 1, 2, 5 tests, it takes a lot of time, and during this time, EvoSuite can run 5, 10, 20 epochs and break through plateau on its own. And that's why we came up with a new approach. The idea was to use KEX as a mutation. So after crossover, before mutating in EvoSuite manner, we are looking at a test and considering whether we want to apply KEX or not. If yes, we are collecting constraints. We choose and invert path calls. It means like we choose what new branch we want to cover. And in these new conditions, we are trying to find a solution. And that's how like this mutation is completed. After that, the process is like basically the same. Let's look at the example. Assuming that we have this type of class, the problem here is that we want to cover this line. However, for covering it, we will need, if we use only KEX, we will need to somehow test only bar because KEX does not generate sequences of calls, and KEX will try to set inner value because KEX ignores privacy. And if we use only EvoSuite, it will take some time to find the test case that calls foo and after that bar. And it will take some time to find the concrete values that we want to see here to throw an exception. However, if we will use both of them, the strong side of EvoSuite is that it can generate a complex sequence of calls. And the power of KEX is that it can solve nearly everything you want. This is our example on the left. And let's assume that EvoSuite generated this kind of test case. It just sets 3 primitive values, and it creates an object, and it calls foo and bar. As you can see, this test does not throw an exception, because even though inner in foo is updated, it does not passes through the check in the bar. After we have this test case, we are just basically inlining bodies of every method. Inlining foo and bar is pretty much straightforward, and the constructor is also inlined. This is some kind of dummy call, but you can see here that we are setting A and inner values in the test case. So basically, we can see in this code everything that happened to every value, field, primitive, and so on. After we have this kind of test, we are removing all the primitives that we have in our test. Like you can see that we removed A, B, and C. We remember what was covered by this test. We know that this line was covered, this branch was covered, and this branch wasn't covered. We just remember it, but all the values are erased. After that, we are collecting state for the symbolic execution. We are marking A, B, and C as symbolic constants that we will need to find out. We remember that field A of an object is value of A. Then we need this kind of condition. Then happens this, and then these 2 conditions. That's the symbolic state that we pass to the KEX, and we want KEX to solve this. Not to do this, but yeah. After that, we are choosing what we want to cover, what branch we want to revert and cover. And after analyzing what will bring us to the uncovered case, we are deciding that the last condition is the most interesting for us, and we want to invert it. After we decided it, we are just passing this state to the SMC solver, and we get some solution. For example, let's assume that we got this. After this, we are just changing all our primitives that were obtained by SMT. And we can see that basically what we did, we changed some of the lines, especially primitive definitions, and that's a mutation that we wanted to see. We had some challenges along the way. And the first one was to, like, how should we apply this mutation? Because if this mutation will be applied 100% of the time, it will take too much time, and we will not succeed in anything. The first idea was to apply at every epoch with to every individual, but with some probability. We tested it with the probabilities 0.5, 0.25, and 0.1 to test out what was the best. And as you can see, 0.25 was somehow the best one. Another idea was to apply only on plateau epochs. It was inspired by previous version. If we detected a plateau, we can try to apply this mutation to everyone, to every individual, or to every individual with some probability. And as you can see, the results for plateau version are much higher. And especially with the plateau, when we apply on plateau to every individual. Yeah, weighted line coverage, I need to explain it, I believe. Weighted means that we give some priority to the big classes being covered. Yeah, so the bigger class is, the more weight it has than the small ones. The next challenge was path close selection. What we need to do, we need to choose a condition that we are going to change. First of all, we need to filter out the ones that we cannot change. As you saw, we are mutating only primitives, but not every condition depends on primitives. For example, instance of are not they are not depending on primitives in any case, as well as null values. However, these kind of primitives, this kind of conditions can be dependent on primitives, can be not, and we need to analyze it, and we have done it with data flow analysis. We need to check every part of condition to be primitive dependent. Here we can see that 0 is a primitive, and here we can see that 0 is a primitive as well. Yet, not the examples, but okay. We need to analyze as well if A is dependent on a primitive, and we can see that it is just call of foo without arguments, and therefore we are not seeing dependency right here. But if we will dive into foo, we can meet there a primitive dependency of return value, and therefore it can be dependent on primitiveness of something, and it should be thought about. Second problem with path close selection was after we have marked all conditions as we want to cover them or not, we can somehow mutate them or not. The clauses have different priorities. So for example, here, let's assume that green lines are covered and red lines are not. And we have a choice between changing A greater than C and B is equal to C. And what we want to do here is we want to count so-called distance to uncovered code. And for this condition, A greater than C, this weight is larger because it changing this condition leads us to a call, and the call leads us to whole new code that we want to cover, and therefore calls have larger weight, and therefore we want to A be less or equal to C. Yeah, and this is the comparison of 3 methods without any filtering, with a simple filter where we just skipped instance offs and null checks. And the third one was this whole data flow analysis filter with smart choosing depending on distance to uncovered code. It was gathered on Guava project. That's why digits are different. But still, you can see that data flow analysis is brings much more coverage than it could have. Another problem was alias analysis that I mentioned a little bit earlier. Imagine that we have some kind of test case, for example, that's on the left, and we can easily understand that obj itself is primitive dependent because it has a field that is equal to A, that is a primitive. However, after we are assigning obj to obj2 and checking this condition, it is not obvious whether obj2 is pointing to the same memory, and this obj2 dot field is primitive dependent, and we need to check it, and we need to understand that after assignment, all primitive dependency thing is moving to the new object as well. Another interesting problem was arrays. They are always the problem for symbolic execution. And here is an interesting case. As you can see, we have one primitive value and one not primitive value. And here in this condition, we need to understand whether this is primitive dependent or not. And to do it, we're just marking all array values are primitive if one of them is. Here, the zeroth value is primitive dependent, and therefore the whole condition, not depending on what the value of the C is, it should be primitive dependent, and we need to assume that we can somehow mutate it because of aliasing, because we can access this value in different ways. Last but not least problem was representation and consistency. The thing is that EvoSuite is a pretty old tool. It was designed for Java 8, and the Kex is pretty much a new one. And therefore, we need to somehow fix inconsistencies between representations, because EvoSuite has its own, Kex has its own. We need to translate one to another. And the problem is that EvoSuite has mocks and some strange statements without any proper documentation. And we need to somehow transfer from one representation to another. And it was done by instrumentation. But, well, we need to instrument all the test cases that are generated. And it is pretty much hard task, time-consuming task, I mean, because there are a lot of tests, because we have a lot of epochs and a lot of individuals in every epoch. Therefore, instrumentation takes a long time, and as you can see, the statistics here says that a lot of tests, 18%, are containing mocks and therefore cannot be processed by Kex. Therefore, we need to throw them out because we cannot do anything. And yeah, here are the results for our project. As you can see, our results are slightly worse, but I believe that it can be said that it is not that big margin. Here's the thing. As I mentioned earlier, Kex is a pretty much time-consuming tool, and therefore EvoSuite is pretty powerful enough. And not that many tests can be affected by primitives in this particular benchmark. Yeah, and here are the plots for these benchmarks. You can see that blue line is a coverage for our project, for our tool, and the red one is for EvoSuite. And you can see that even though in terms of number of epochs, EvoKex finds faster, like it uses a little number of epochs, but in terms of time, it has some disadvantage, and it's pretty obvious. Here is another example that shows it better. You can see that they both reached 100% coverage. However, EvoKex managed to do it like 100 or 200 of epochs earlier. However, in terms of time, it was pretty much the same. As for future work, we can do different things. For example, the main one, I believe, that we can implement our own SBST approach, like our own SBST tool instead of EvoSuite, to ensure that we understand like how it works. We will fix this inconsistency among the representations. We will understand what it is, how does it work, and we will not use any legacy code that is always hard to use. Second thing is implementation of concolic execution integrated into the whole pipeline. It is basically the same idea, but from the other side, we can not try to adjust EvoSuite to our case, but we can adjust Kex to our case. Third idea is that, as you saw, there are not many primitive dependent conditions, and we can get a new benchmark that will have stronger primitive dependency, and we will have more reasonable results. And yeah, the fourth one, as always, we can try to come out with something new and do something new in this field. That's it for me. Thank you very much. Any questions?
So yeah, to begin with, I'm questioning my understanding. Is it true that in your current implementation, EvoSuite is the part responsible for the structure of the test, while Kex is being used only to change the primitive values to cover specific parts?
Yeah.
So if EvoSuite fails to create somehow a proper structure to reach something, then Kex will not help it.
Well, basically what we are doing that, yeah, we are taking the structure that was generated by EvoSuite and we use it as a template for Kex.
Okay.
Even if the structure is not that good, Kex pretty much always can do something new to it.
So Kex is allowed to.
Yeah, of course.
Okay. Any other questions?
The conditions of quality to null are not considered.
Well, the thing is that you are how does this null checks work? Like you have a statement, for example, object is assigned, null is assigned to object. You cannot do anything with primitives because you need to replace null with some call of the constructor usually, and vice versa. Well, it is not that interesting because like EvoSuite always is powerful enough to generate nulls that are assigned to values.
There may be a branch that's under some hard condition which assigns null or not null, and after that another branch that will check for null, and maybe not like instance of is. I understand why instance of is not so easy model them, but equality to null and inequality is like a binary option, and it's maybe modeled to like a Boolean, maybe.
Yeah, it might be. As I said, if you have some kind of variable that is null initially, you cannot do anything with it because like you need to replace null not with some value, some specific value, like for int. You cannot just write 2 there. You need to call a constructor, and it is a task that well, it can be solved by Kex, but here is the thing that Kex will just ignore all privacy and will say that you need this structure with these values of these fields. And we cannot do it in EvoSuite manner. And vice versa, if you have some not null value, you can replace it with null value. Yeah, but we were focused just on the other thing. We wanted to understand how we can change some primitive values like ints, strings, enums, and so on, and to somehow control the execution of the program.
I think I can also comment on that a little bit. Basically, yeah, what Timur said, that Kex in theory can generate an object or even a constructor call, for example, if we adapt it to work like that, to be able to cover null checks as well. But in that case, one of our motivations was that we didn't want to make Kex generate new objects because it's a harder task than just here's the formula, fill in the primitive values. So even though it's possible in this work, we also wanted to focus on what can you do with primitives. Or no?
I just maybe it's possible to consider object like Boolean with two options, like a constructor calls that were generated by EvoSuite or assigned to null. Like you do not have to generate a new object, but only change to null or vice versa.
In theory, yes, but yeah, we haven't thought of that and didn't focus on that. But yes, it is possible. Another thing I would say about null checks and what Timur mentioned with like reverting something from being an object to being a null, the way EvoSuite works in most cases, it will first generate null and then it will generate object, for example. So this is just my kind of guess based on my experience, but I would say that in a lot of cases, you cannot replace null with a constructor call yet because most probably EvoSuite haven't tried to generate a constructor call there.
Any other questions?
I have a question. If we go back to what you said in conclusion about that we can try to add, concolic execution. How exactly do you envision that? Can you like explain in a bit more detail what we're gonna be doing in concolic style and how that would help us to be faster?
Well, yeah, the idea is as always like we have this inconsistency that I mentioned in test representation, and we need somehow to integrate these two tools so that they will work together, and we don't want to have this instrumentation in the middle that will just take some time to do the thing that we can do manually in the first place. That's the thing that I was thinking about when I wrote this part. Like we need to have this inconsistency removed on the stage of structure.
Got it. Then I have another question. So when you were talking about no, let's do it a bit differently. So like thing number one, we're achieving, like from the results that you showed on the SBST 2023, we're achieving almost the same coverage using less epochs because like each epoch takes more time because we're going for Kex, but the like overall coverage is like 85 versus 86%. So that means that like if we speed up Kex, that would be an improvement. Do you have any insights of how to phrase that? So what can we do to speed up Kex? Do we have any parameters like meta parameters, if you will, that we can change within this problem that you're working with to try and speed up Kex besides the one that you already talked about?
Well, there might be something, but it is unknown to me what we can tune in the kex so that it runs faster. If it is possible to run kex faster, I believe it would have already done.
That's a good trick. So like, then my next question, just like probably you don't have an answer, but did you like what you're doing? You're saying this is a mutation. I'm gonna take some variables. I'm gonna say that they are symbolic, and I'm gonna try to ask X to find interesting values for these variables. Did you see if which variables you take as symbolic and which variables you preserve as concrete generated by EvoSuite, if that impacts KEK performance significantly? Because maybe if we just take not like all 5 variables, but we take 3 of those variables, keep some 2 variables fixed, and that's for understandable reasons make KEX perform faster. So have you taken a look at that in more detail, or you didn't consider that at all?
No, we didn't consider it. It is an interesting idea. However, like, yeah, it will make kex faster because it have less freedom, but also it has much less control over the execution of the test. Yeah, we didn't consider it.
Yeah. I'm just saying, like, basically, this is like, we have this opportunity to go in between fully symbolic and fully concrete execution. And you can just try to find, like, because we're not working with full-blown, like, concolic testing, we just want to improve what EvoSuite does. And maybe there is a sweet spot that makes KEX still, so it gives KEX enough flexibility to try to find the best symbolic values. For some variables, that opens up new path, but it doesn't give KEX too much freedom so that it starts being slow. But that's just, I understand, that's just an idea that we can try going for forward.
That was the next idea.
Sorry. Okay, Tatar people think alike.
Yeah, I don't see any other hands. Sorry.
So, the other people already talk about trying to modify KEX. I'll try to come from other side. Is EvoSuite anyhow an open tool, or do you use it as a black box? Open.
No, it is an open tool. Like that like we integrating this kind of mutation in EvoSuite thing. The problem is that it is legacy code. It is from like Java 8, and it is very. We need to. In the best case scenario, we need to rewrite it from the 0, and it will.
In Rust.
Yes, especially in Rust. And the problem is that it is very hard and time-consuming and people-consuming problem.
Yeah, I haven't asked my main question yet,
Or-
but yeah, if you're trying to specialize KEX to give you concrete values, have you tried to specialize what EvoSuite does? So it will mainly focus on making modifications to the structure, not to assigned values. Because as I see it now, you can change the EvoSuite mutation and crossing over process so that at least some of its changes may apply to values which you overall ignore because you still run the KEX on it.
It's an interesting idea. The thing is that if we will, we can try to do it. We didn't do it, to be honest. But limiting the change documentation for EvoSuite can be can turn out bad because it changes not only like primitive assignments but also calls. It yeah, I understood what you said. We didn't try it, and it is a good idea, I believe. Yeah.
Yeah. By the way, have you checked which lines, which branches remain uncovered? Are those branches with hard conditions? Are those branches that need complex structure, or are those something else?
We didn't. We did. As for me, I didn't personally check it, and I believe that
There's something in common along the you haven't covered.
I believe I don't see Mark's hand right now, so That's it, I believe.